I think we are ready to start. Just let me add all the platforms so that we can stream everywhere. Okay, guys, let us know, as usual, if you can see us and if you can hear us. Let us know in the comments. Hello to everyone joining us. It's 11:30. We already have some people joining us, especially as I can see on YouTube. Hello, guys. Hi, welcome back to SForce Summit 2022. It's the third day, but we are not losing our energy because we have still so many topics to cover. And as you can see with me, I have Michal Drazil, who will tell you a bit more about predicting customer churn with Einstein Discovery. Now, Michal represents our proud sponsor, Mooza. He is an experienced Salesforce consultant, team lead, and CRM and data specialist with strong analytical skills and more than 12 years of experience in several data and BI related roles. An enthusiastic trailblazer passionate about data analytics, data visualizations, and tools such as Tableau or Einstein Discovery that he will be telling you a bit more about today. He has successfully delivered projects within various industries, mainly banking, insurance, and telco. We are really proud and really happy, Michal, to have you here with us. Now, I will be leaving you with our viewers in a few moments, but just let me remind everyone that we will hold a Q&A session after this presentation. So if anything is particularly interesting to you guys, please leave your questions in the comments. Also, you can send them to our mailbox. We will be showing all of them during the Q&A session. Okay, Michal, so have fun. Great to have you here.
Thank you, Dorota. Thank you so much. Hello to everyone. I'm super glad that I can be here with you today. Thank you for joining me, especially during this lunchtime. And let's start. Thank you for the introduction. I will just quickly tell you something about our company, about Mooza Inspire. We are a European Salesforce partner. We have offices in Czech Republic and Poland. We were founded in 2017. During those 5 years, we were able to deliver projects within 18 countries to more than 150 customers. At this point, we are around 50 employees. Okay, there is another slide about me, but I will not stay here for long. Maybe what is interesting is that I'm Tableau CRM and Einstein Discovery certified, which is the topic I'm gonna be speaking today mainly. Okay, let's start. And there is a first alert. There will be a quiz at the end of my presentation. So if you want to win one of our lovely prizes, please pay attention, and I will wish you luck at the end. Okay. Next slide. What is predictive analytics? I will start with some theory here to get the baseline before speaking about the specific tool. So this is my favorite visualization or slide about 4 types of data analytics. Let's start with the first one, which is descriptive. This is the simple one, I would say. When you are just basically describing what's happening, you are finding the data and trying to visualize them and describe what you found. Next level is when you go a little bit deeper and try to answer the question, why is something happening? So you're drilling down through the data to find the root cause, and try to find some insights about what is happening, giving the why answer. Predictive, which is the main topic for our today's presentation, predictive analytics, it's answering the question, what's likely to happen, what will possibly happen in the future. So you need some historical data you analyze, and then based on this historical data, you are predicting what will happen and basically look into the future. And the last and the most advanced data analytics type is prescriptive. And this is about what do I need to do about what I learned and what I predict. Or let's put it differently, what shall I do if I want something to happen for me? So I'm really now deciding about my future. And this prescriptive layer is involved or is present within the tool, the Einstein Discovery, I will be speaking today as well. So it will be about predictive plus prescriptive analytics. Okay. What do we usually need to start with Predictive Analytics Initiative within our company? Let me put it this way. I would say there are three main pillars. The first one, there is no doubt, you need the data. Without the data, you will not be ever able to get predictions or so. So you need to store the data about your business, about what you're doing. It doesn't really matter if they are, let's say, financial data or data from your ERP system or your CRM, but you need to store the data. On the other hand, I would say every company does that these days. There is usually a history of several years at least, and but it might be obvious, but yeah, that's just how it is. Data is the first point. Secondly, you need to have some knowledge. You need to know how to manipulate the data, how to model statistically. There are quite popular tools like Python or R programming or so. So you need to have the knowledge. So either you are building some, let's say, in-house data science or data analytics team, or you can hire the external consultants who will help you to achieve this task. Third pillar is the technology, because these kind of applications are usually quite demanding when it comes to hardware requirements, to, let's say, CPUs and so on. So you need to have hardware on-premise or public cloud, doesn't really matter. So you need to have some software which will help you with this machine learning or data modeling, and obviously you need to have a data storage for as a source of your data. Usually you have something like data warehouse, data lake, or so. Additionally, you may need obviously some licenses as well. Let's say this is the traditional approach. Usually this is not a cheap thing. Maybe I will go one more time back, that the technology costs something, but mostly the second part is something which you need to invest in, to have the special knowledge, to find highly educated specialists. So this is maybe the entry barrier for most of the companies, and that's why mainly the big enterprises and big corporates are able to have a big analytics team. But what if you have Salesforce, aka the smartest CRM? You probably heard the name Einstein many times with the Salesforce CRM, and it is really true. It's really smart. Let me maybe start with one definition, or one lately popular term as well, which is citizen data science. Here is the full definition, but I will not read it basically. But citizen data science is about bringing data science closer to the people, to the masses. As I said before, there are highly skilled and educated data scientists needed usually for building predictive models. And let's face it, these people are scarce. There are not enough of them on the market. So every company which might be interested in data analytics and predictive analytics and machine learning, so not everyone can find them, can afford them. And that's why this citizen data science is about bringing some automatic machine learning tools to the company, which does the trick, or which helps you seriously to use the benefits of machine learning in your company. So it automates the data science tasks. You usually do not need some extensive coding skills. So these are the favorite no code or low code tools, and it reduces statistical modeling. What you obviously still need to have is your business knowledge, a domain expertise, and you need to know about the business you're working with. Plus, you need to ability to interpret results of this machine learning model statistically. So you need to be able to read it. So the citizen data science, this isn't a role. This usually means that someone within the company, like marketing manager, CRM owner, CRM leader, data analyst or so, is able to work with these tools and to read their outcomes. By the way, I'm the same case. I'm definitely not the, let's say a data scientist from the university with a super strong statistics background. So if we have Salesforce, we are close to this predictive analytics with basically two tools that are available. The first one is Einstein Prediction Builder. It's let's say entry point to some advanced insights about your data, and as well it's a low cost or definitely a cheaper option to find some insights. It's meant for mainly Salesforce admins, and you are allowed to create predictions based on Salesforce fields within your CRM, and you can then power workflows, embed some scores in the pages and list views and so on. If you are more serious about machine learning based on your CRM data, you have this Einstein Discovery tool. This is a part of Tableau CRM, or formerly known as Einstein Analytics. It is used by the data experts, but you get something extra here. You are able to work with external data, not only Salesforce, but as well your, as I said, ERP data, additional databases, SQL data, cloud data, and so on. You can use millions of combinations, up to billions of rows of your records, and you get more detailed insights and the prescriptions as well. So not only why it happened, but what should I do as well. There are other features within Salesforce with this Einstein word in the name, like Einstein Next Best Actions or so, but I will not be speaking about it today. Okay, quickly about the Einstein Discovery, what this tool is about. And I think this is one of the last theoretical slides before I will go to the application, but just to understand, Einstein Discovery is this machine learning or predictive analytics tool, and obviously it's not meant for every possible application. There are some pros, there are some cons as well. So why we are or what for are we using Einstein Discovery? Usually for answering a yes or no questions like, will this customer churn, yes or no? Or will this customer or will this invoice be paid on time, yes or no? So these kind of questions, or how much or how many. So how much, or how many, how much will this product cost or so, for how much will it be sold or something like that. It can give you as well some factors and help you understand the factors that influence your target metrics. So this can be this churn metric or price metric or so. You can get another insights in, let's say, statistical significance about if something is really important in terms of statistical significance or not. You can get explanations and find patterns within the data, which you will not be able as a human to just see and find without doing some advanced calculations. And lastly, as I mentioned before, it's able to give you some prescriptions. What shall I do? But there are also some applications that are not good for Einstein Discovery. For example, finding some anomalies in your data or identifying frauds. This is not the correct use case for Einstein Discovery. And same for, let's say, market basket analysis. you know this, like you bought beer, probably you may want to buy potato crisps as well. So these kind of recommendations based on your market behavior, this is also not something you can get from Einstein Discovery. Same applies for analysis of the natural language. Okay, now I will tell you something more about the real project we were delivering in the previous months within Mooza. And it was, the use case is quite popular or common, I would say. The client was the startup company who works in a hospitality or accommodation services, and they obviously have several thousand of clients, and they want to be able to identify which customers may possibly churn, and they want to act on this. They want to prevent it. Obviously, this is, as I said, this is a quite common use case because it's it's a common truth that it's easier to keep the existing customer and to prevent him from leaving than just lose the customer and get a new one. So that's why companies invest in these predictive and churn models, and it's quite popular within financial companies, telecommunications, and so on. What was actually the main challenge here, that and it's a common thing again, that the number of records was not that impressive. It was around 4,500 accounts, and it was the history of few years. But for super strong predictive models, you usually want to have more data than a few thousand records. Let's say hundreds of thousands of records is definitely something something better, but still we were able to achieve and to deliver, let's say, quality predictive model here. Okay, here are already the details about the model. As I said, there were approximately 4,500 accounts. We needed to exclude some of the accounts from the model. I mean, prospects or lost accounts, which in fact didn't do business at all with the client company. And we had a history of 600 churned accounts. This is the important indicator, obviously, because we need to teach the model on these 600 and mainly. So this is it. And here we are, let's say, somewhere around the bare minimum for this Einstein Discovery tool, which is 400 positive examples. So this was the big challenge. Training and validation data sets. This is another quite important term and concept used within machine learning. Actually, as I said, you need a historical data to train the model on, that to find the patterns and to be able then to apply it to the data that has not been previously seen. Or so this is it. You train the model on one set of data, and then you need another data previously unseen by the model. So you test how good the performance is. So either you have some separate data set, maybe from an archive or some different data you will just then use for this testing, or if you do not, you need to put some data aside. And this was the case. Actually, from those 4,500 records, we used 70% for training and 30% for the validation. And those 30%, this is the performance you're interested in, how it performs. And I mean the model, how it performs on the data that is unknown to it. So yeah, that's the concept here. Just for the record, what we were using as the final model, it was gradient boosting. It's one of the binary classification used. You know, you have these regression, linear regression models and tree-based models or so. This is one of the tree-based. I will not spend any more time here, unfortunately, because this would be for, let's say, another statistical session. But maybe just to mention, this is usually an iterative process, this creation of a predictive analytics model. And there were about 40 versions before we got to the final one. On the right side, you can see how the output from the Einstein Discovery looks like. And it basically, after the model is crunched and ready, it will give you the highlights, like when did customer churn occur the least and the most. So you can immediately get a first insight about your data. Okay. Let's focus on data preparation for a while, because this is another my favorite quote: garbage in, garbage out. And it's simple like that. If you provide bad quality data to the model, you will get bad quality outputs. So it is simple as that, I would say. So data preparation. Let me maybe mention first, or I can't stress this more, that this is a crucial phase or this machine learning initiative. No matter what tool you use, or if you have a specialized data scientist, this is really the core. You need, and you probably will spend majority of time and effort here in order to get the best quality model as an outcome. So let's say this traditional 80% of your effort will be within this data preparation. You need to gather the data, collect them from all the sources. You need to be able to connect them. And you, of course, need to understand them from business point or business perspective. There are some typical issues. You have values missing. You may have duplicates. You need maybe to enrich the data by combining them with some other sources. You may have even, and it's quite common as well, that you have some data in your Excel sheets or CSV files, but they are still important, and they can raise the quality of your model. So this is the part. Well, you combine all the data sources you have, and actually what you are doing is you're building Tableau CRM data set. This is what I mentioned. The Einstein Discovery tool is part of this whole Tableau CRM. So this is basically the same, and no matter what you will use the data set for, if it's dashboard building or if it's working within Einstein Discovery. Obviously, you need some data modeling skills here. You need to know some database concepts about, let's say, SQL, joining the data, and so on. So sometimes there are different people working on the data preparation than on the actual statistical modeling. So yeah, that's just how it is. Okay, let me comment on the data preparation phase within our project we were delivering. Actually, this is a list of all the fields we got from the client, and which they was suspecting basically that may be a factor influencing customer churn. So we took this list and needed to process it. We were using Tableau CRM, so-called data prep, and combining the data, doing aggregations, doing filtering, and basically the goal here is to build one big data set of everything you may possibly need at the end. So basically this is a screenshot of the part of the data prep from this Tableau CRM. Okay, so let me explain what Einstein Discovery story is and why it is important. Actually, the outcome, or what you get after running Einstein Discovery, this is called a story. So whenever within Tableau CRM you see a word story, it refers to Einstein Discovery and statistical modeling. As I already said, it is actually the iterative process. It usually doesn't work like that. You have the data, you run Einstein Discovery, get the story, you're done, and all is great. You need to do it several times. You need to basically act on various warnings. You need several decisions to be made. You need to really evaluate the outcomes and read the model statistics and so on. There are also, let's say, some challenges and limitations. For example, you can have up to 50 columns to be analyzed by Einstein Discovery. So, for example, if you have 100 columns and you are not sure which columns to use, you need to split it into several models and analyze it separately, and then decide which fields or columns will be interesting for you. At the same time, there is a ratio between number of rows and number of columns you can use for a quality model, let's say. It means that more is not always better. If you have, let's say, a few thousand records, I mean rows, you can't expect that the model will use 50 predictors, because it will not work that way. If you want to use 50 predictors, you probably need to have millions of rows to be analyzed. So I will be speaking about that in a second. Segmentation. Sometimes it's better to split the model into several models, actually. Multicollinearity, that's another important term to understand or know. Basically, this is the situation where two or more explanatory variables are highly correlated. What does it mean? Let me give you an example. For example, if you have a city and a state fields within your data, it will actually probably be the situation that one city is always within one state. And this means there are two basically columns basically meaning the same, and you can't have it because it will influence the quality of the prediction. So you need to decide on these kind of fields that you will keep just one of them. And there are, of course, some more advanced situations where even you may not know that two variables are highly correlated, and that there is something you need to do about it. Overfitting. Overfitting is a term usually meaning that there are too many explanatory variables, and that the model performs super great at the training data set, but in fact poor on the real data, on the validation data set or your real data. This is obviously, usually the results are better on training data set, as this is the model where you're learning and finding the patterns, but you want to have just a little bit lower performance on the real data. And for example, cardinality, I will give you another example. For example, if you are selling more than 100 products, let's say 150, and you want to use a product field as a predictor, then you will not be successful in these terms, because actually only 100 distinct values can be provided to Einstein Discovery. So you need to do something about it. You need to group it into some bigger segments, maybe use a product category instead of product or so. There are several techniques how to overcome these issues, but this is the type of challenges you need to think about and you need to tackle. Okay, a real example. From this, let's say 50 columns we got really from the client at the beginning, let's say 12 made it to the final model, and then we were doing actually, we were removing a few of the predictors, actually the top one and bottom four. So we ended with actually 7 predictors. Here you see the correlation or the influence on the target metric. So as I said, with a few thousand of records, you can't have 30 predictors or more. So we ended up with 7 actually. And this is another screenshot about how it looks when you run the Einstein Discovery story. You get some insights, and you can spend a lot of time there, because this is just one small example, but there are almost hundreds of them, and even combinations of the data. Like if one predictor is A and second one is B, the target metric performs better or worse or so. What is great actually here is that it's not a lot of statistic coefficients or so. This tool is speaking to in a natural language. You can easily read it and understand what are the insights found within the data. So this is the example. For example, we analyzed territory as a field, and we got immediately some insights that, for example, Benelux territory is lower, so we're doing better in Benelux. And then you can dig deeper and try to find another factors that influence that Benelux is below the average. On the other hand, let's say this territory is performing worse. Special factor is, of course, when for example territory is null. Maybe there is another reason for this happening, and but let's not focus on this one. What is also interesting is like these blue and gray colors, because the blue ones are those you should be interested about, because these are statistically significant. The rest is, let's say, around the average, or in terms of statistic non-significance. So this is the type of outcomes you need, and you need to analyze them. And probably there will be another iteration where you play around about the data. Okay, how good actually is my model? This is a crucial part of my presentation, I would say. You don't have to be a data scientist, actually, as I already mentioned, but you still need to understand few concepts and terms, maybe some basic statistics and so on. So let me give a super quick overview of this. There are several charts here, so-called model metrics or so. As I said before, there are actually 7 predictors used. But let me start with this confusion metrics. This is actually something I really like. It's a simple metrics, and this is probably the first point where you will take a look after running your Einstein Discovery story, and it gives you the overview of the quality of the prediction. First of all, I will probably mention that let's face the truth, nobody's perfect, and no predictive model is perfect. You will have false predictions. You will need to face this, that we are not, or any model isn't able to predict everything correctly. So what we want to get is actually highest possible true positive rate and true negative rate. This is when the prediction was the same as the reality. On the other hand, there obviously will be some false predictions. So you have false positive and false negative. What does it mean? False positive in these terms is the situation when the model was predictive positive churn. So the customer will churn. Actually, the actual result was negative. So we predicted the customer will leave, but it actually did not happen. On the other hand, and what I think, and we agreed with the client, is worse situation and more dangerous to us as a company is this, let's say, 21 false negative. So model was predicting, yeah, this customer will not churn actually, but the reality was they actually did. So we were not able to find 21 customers that actually left. So, and what is great about this is that you can actually set up the thresholds and the combination, which is okay for you in terms of costs, in terms of your business, and so on. So this is something you can play around, and that's why this false negative rate is lower than false positive for this company. But there are more coefficients. Maybe let's quickly have this ROC curve, which is a probability curve. And if I just put it simply, this is showing the rate of true positive versus false positive. So this is and by these thresholds you are moving around this curve. What is also a quite popular coefficient used here is the AUC, or the area under the curve. So actually we are speaking about this area, and we want to have this area as big as possible as we can. The explanation here is that if we have AUC 0.5, it actually is the same as a random guess. If you have AUC close to 1 or exactly 1, this means you build a perfect model that is able to predict everything in all cases. So it means if you really have model with like 99 AUC or 1, you probably did something wrong, because perfect model does not exist. It should give you the information to get back to the drawing board and find the mistake. So by the way, our AUC for the final model was around 93%, which is quite okay, I would say. 2 more charts or graphs, and I love them so much. These are great metrics and are easy to understand. Let me explain it to you. This is so-called gains chart or lift chart, and this is cumulative capture rate. What we have on the x-axis, actually on both charts, actually is just a percentage of the customers you scored. So, and the order is from the top score to the lowest one. So you just get the score and you order it in descending order. And these are the customers with the highest score in the predictive model. Same here. And how do we read it? So let me find, for example, this way. We have here 10% of highly scored customers by the model. And this is telling me, actually, if I focus on these 10%, I will get 6 times bigger chance of finding a possibly churning customers in comparison to that I do just a random pick. If I pick one customer, I have like 50-50 chance, right? But if I apply the model and focus on top 10%, I get 6 times bigger chance of finding. So it's probably good to pick up a phone and call the customer saying, hey, how are you? How are you doing? All good? Is there anything we can do better for you? And probably you should find a customer you may lose. Same here. Actually, this is something about cost efficiency. Let's say that if you focus on top 20%, so you pick your phone and call 20% of highly scored customers, you should already find or have already found 80% of all the possibly churning customers. So you don't want, in fact, to call like half of your customers, because then you will find like 99% of possibly churning customers. But if you call just like 15%, you still are getting to 80% of your possible losses. So this is obviously about how effective you want to be, and this is the value the statistic model is bringing to you, actually. Okay, so we have our model. We are happy about it. So are we finished? Are we done? And no way, because predictive model is actually never finished. This is ongoing work. This is something you need to take care about the long term, and basically analyze the accuracy and performance. Because another sad fact is that actually all the model deteriorates, or every model deteriorates in time. There is something which is called data drift. And this means that there are factors of changes within your data there are factors around changes in your business actually. So you really need to, after you start using the model, you need to take care about it or pay attention to the model performance, and from time to time you need to refresh it, maybe do some adjustments, because there are just standard changes happening in the company, in the data, or so on. So, but before you even deploy the model, it is a best practice, I would say, to give it to the stakeholders or to the business people. Maybe give them access to actually take a look in this Einstein Discovery, to read through the insights. And this is a first, let's say, testing you do, because the real business users will say, okay, this probably makes sense. We did not realize it, but yeah, we really have a problem in Benelux territory or so. Maybe there is a new salesperson or so, or something like that. Or, which is of course more important, you can learn like, no way, this can't be true. This is just nonsense. The model is saying something which actually can't happen in the business perspective. So this is just some mistake within the data or so. So this is quite important, because you will never know the business reality as good as the employees of the company or of the client or so. But if you are able to go through this phase and you don't have to recalculate your model, you deploy the model and start using it. So in this case, obviously, you deploy it to Salesforce as your CRM and start using it. You can apply the model to actually several places. You can use it in list views, you can use it in reports, you can build some automations based on the score of your prediction or so. You can build Tableau CRM dashboards. I will show you just a small example at the end of my presentation. And the third part, this is something I already mentioned, that basically you need to analyze the performance or model accuracy in the time. So you probably want to refresh it. You can do it even automatically, or let the tool do it automatically. And you wanna obviously analyze if really what your model predicted, if it really happened, and what is the rate, what is the percentage of this, in how many cases you are basically predicting the truth, and so on. So it's a constant work, never ending actually, and you need to pay attention to it, just that you can't just deploy and forget. Okay, how do I use it? That's the example I was speaking about. Actually, in Salesforce, you can use this great component, for example, on Lightning pages, where you will see the score, but you will not only get the score, you can actually get top predictors why the model is basically predicting this. And what is absolutely greatest is how to prevent this, or how to improve this. So in this case, for example, it means that probably if you apply a different customer service level to this client, to this high touch, it will significantly lower the score. So probably with high touch clients, you have different approach, or some additional services you provide to them, and so on. So this is something you can do, and of course, it really depends on you as a business or decision maker, if this is something you want to consider, because it will cost you more, obviously, or not. So this is one example. Second example is this list view usage, like the percentages prediction in that. Or lastly, actually some, for example, Tableau CRM dashboard where you can have this churned pipeline or possibly churning accounts dashboard where you can combine several statistics, number of accounts, average churn probability, and so on. So you can have a even, let's say, detailed card about some hotel and their performance and why, and so on. So the possibilities are endless actually here. So this was it. I think I'm at the very end of my presentation. I would say I'm on time as well. And before we get to the Q&A section, we have this quiz I was telling you about. And before I go to the next slide, actually, because this is time matters here, you need to act fast. So I will not present it now. I will maybe explain the details. On the next slide, there will be a QR code. And at the same time, Dorota will paste the link in the comment section. And you just click the link or scan the QR code with your mobile phone. And there will be 3 questions, 4 possible answers. Only 1 is correct, actually. And the first 3 contestants will get the award. We will contact you by the email. And okay, now I'm turning to the next slide. And that's it. Now I can tell you more about the prizes we have. As I said, 3 top contestants will get one of these great prizes. First one is the Salesforce Mooza backpack. Second one is branded sleeve for the documents or a laptop. And the third one is pair of wonderful Salesforce socks. So good luck. Hope the questions are not super challenging, but if you paid attention, I hope it will be quite easy for you. I will leave this quiz QR code for some time here. And now I believe there should be a Q&A section. So asking Dorota.
Yes, of course. So let me just confirm, as you showed our viewers the QR code, I also put the link to the quiz in the comment section, so you should find it out there. It's the link that you will find in the comment section. Now let's go to the questions. Oh, one of our users left a message. Great presentation, thank you. I'm unable to finish it because I got to work, but it's a great demo. I really appreciate it. Thank you. Thank you so much.
Great.
Thank you so much. And now for the questions. Okay, I believe this is the first one. Is it possible to test Einstein Discovery, or do you have to buy a license to see it?
Actually, I think there is always possibility for some, let's say, development purposes to get a demo org. In these terms, I'm referring maybe to Trailhead Playground. So if you're interested in general in Tableau CRM as a topic, which part is Einstein, which is Einstein Discovery part of it, please navigate to trailhead.com, find Tableau CRM or Einstein Discovery related trail mixes, and there is the option to apply for a free playground which has Tableau CRM enabled. And for, of course, personal usage, you can play around and learn the tool in a better way. So this is the option for non-commercial usage, I would say.
And a similar question, I believe, we have out here. How can I start learning and playing around this if I don't have enough data?
Okay, great question, and thank you for the interest here. Obviously, as I said, data is crucial part. You need to have, let's say, few thousand of records at least to play around. So if you or your company does not really have the data available, or you're not allowed to get them or use them, there are plenty of, let's say, public data sources or open data available on the internet, and there are even portals or servers which are good for this. I hope I can maybe paste a link to our, can I put something in the comment section? There is a server called Kaggle.com, KAGGLE.com, and this is a great place to start with the training or learning how to apply machine learning. And there are plenty of data sets you can download and use them for free. Or maybe I will just type it here in the comment section, and hopefully Dorota can paste it.
Yes, of course, I'm doing it
to it. So or just Google Kaggle, and this is, I think, one of the best sources of free data sets that can be used within Einstein Discovery, for example.
Okay, just give me 1 second. Okay, I'll just paste the link. Okay, this will be the quickest way. So the link that you see right now, as Michal said, Kaggle.com is the one to practice. Okay, and just let me skip to another question that we have out here. Oh, question about the money. How expensive is this thing?
Yeah, that's a common question as well, I would say. Of course, this is not for free. This Einstein Discovery is a part of a license add-on you need to buy from Salesforce. There are public pricing available on the Salesforce side, but just to give you a rough example, you can get it from around the full license is around, let's say, $150 per month per user, but let's say simple one you can still use with combination of Einstein Prediction Builder. It's half the price. It's $75 per month. But obviously, these are the public prices. Maybe reach out to your account executive, and you can discuss what are the opportunities for your company.
Great. And one more question. Of course, if you guys have any other questions, please, this is the moment to leave, because we have just a few minutes left. So this is the one. Can we use the model outside Salesforce as well?
Yeah, actually, another good question. Obviously, this is a citizen data science tool, which you need to pay for, and maybe you don't want to use it only in Salesforce. So there are actually possibilities to use it outside. You can either export the data model or get the R code actually in the R language and use it somewhere else within another tool. Or you can even have, let's say, API exposed, and you can have a REST API endpoint which you can call from one of your company applications or different cloud applications, and you just connect to this REST API. You provide information, and you immediately get the score back, which you can use in basically anywhere. So it is also possible to basically to use it as a REST endpoint or REST service on the internet.
Great. And I think this was the last question that we got in our comments and in our mailbox. So guys, just let me remind you that in a few minutes, in 7 minutes, Michal will start his Q&A session at the stand. You just need to enter the address platforma.sforcesummit.pl/Mooza. There you can find our sponsor and the virtual stand. Please be sure to meet Michal, but also please be sure to check out their recruitation room. You can leave your CV. You can talk about possible job offerings in Mooza. So thank you so much, Michal. Thank you so much for sharing your time, your knowledge, your experience, and thank you for joining us here at the SForce Summit community. Thanks for being a community leader with us.
Thank you so much. Feel free to join us in our virtual room. As Dorota said, there will be also our recruiter, Philip, answering all your possible questions, and I will be there to answer questions related to data analytics. Thank you so much.
Thank you so much, and we hope to see you soon. Maybe we'll be able to meet in person, but we will be sure to keep in touch before the next SForce Summit comes. Thank you so much once again, and see you soon. Bye-bye.
Bye.